Objective 6, which is the last objective in Unit 3, is all about polynomial division. Now, there's quite a few concepts floating around, so the first two examples I'm going to show you are polynomial long division. So I have the first problem set up. Is x plus 8 a factor of this 4-term polynomial? Well, the only way we can figure it out is we can do division. Now, the way you set this up is you take the first term inside, which in this case is 3x cubed, and you simply divide it by the first term of the outside, which is x. And 3x cubed divided by x is 3x squared. So I put this right on top, right there. Now, you multiply down. Now, this x plus 8 is not in parentheses, but since it's a binomial, this 3x squared needs to get distributed to the x plus 8, as if it had parentheses in it. So 3x squared times x is 3x cubed. And then 3x squared times positive 8 is positive 24x squared. Now there's two ways you can look at it. You can say, okay, I now have to subtract this, but I like to tell my students just change the signs, since subtraction is really simply adding the opposite. Change the signs of these terms. If it's positive, make them negative. If it's negative, make them positive. So the 3x cubed is going to become negative, and the 24x squared is also going to become negative. Now add those two terms, and you'll see that this first one cancels. It should always cancel. If it doesn't, you've done something wrong. Now, 15x squared plus negative 24x squared is negative 9x squared. And now you bring down the minus 65x. And you start the process all over again. Take the first term down here, which is negative 9x squared, divided by the first term, which is x, and you get negative 9x. And so this is going to go minus 9x right here. Then the whole process of distribution is going to start all over again. Negative 9x times x is negative 9x squared. Negative 9x times positive 8 is minus 72x. Here's the step a lot of students forget. Change the sign. So this negative 9x squared becomes a positive, and that subtraction becomes an addition. Notice my first terms cancel now like they should. And negative 65x plus a 72x is a 7x. Bring down that last term, plus 56. And do the cycle one more time. Take the 7x and divide it by the x, and you get 7 plus 7. Now do your multiplication one more time. 7 times x is 7x. 7 times 8 is 56. Change the signs. And then add. And when I add, everything cancels out. So the answer to the actual question, is x plus 8 a factor of this? The answer is yes. X plus 8 is a factor. And the reason is because there's no remainder. That's our first example. Okay, for example number 2, let's do the same thing. Let's see if we can use polynomial long division to take x squared minus 3x minus 31 and divide it by x plus 4. First thing, take the first term of the inside, which is x squared, over the first term of the outside, which is x. So x squared over x is simply x. So we're going to put that right there. Now comes the multiplication again. Remember, act as if this has parentheses around it, just to remind you that you need to distribute. So x times x is x squared. X times positive 4 is positive 4x. Now you have to change the signs. So this is going to cancel out, but negative 3x plus negative 4x makes negative 7x. And then bring down the minus 31 and start the process all over again. Take that negative 7x, since it's the first term, over x, and you get minus 7. Do your multiplication with the minus 7. Minus 7 times x is minus 7x, and minus 7 times 4 is negative 28. Change the signs, so this becomes positive, and that becomes a plus. The first terms cancel now. Take negative 31 and add 28, and you get minus 3. Now there's nothing left in the problem to bring down, so you know that's your remainder. So put plus negative 3 over the x plus 4. The next two examples use the shorter method, which is called synthetic division. So example 3 is, we're wondering whether x minus 8 is a factor of this trinomial. And the instructions specifically say divide using synthetic division. So the way we do it is we first take the x minus 8 and we get the root of that, or the 0, or the solution, any number of those terms. But we understand when we set x minus 8 equal to 0, the answer is 8. So we use 8. Now over here we take the leading coefficients of these three terms. Now the leading coefficient of the x squared is the 1. The middle term, the x, is minus 13. And the constant, the last term, is plus 40. Now there's just some mechanics that we now do. We always bring the first term straight down. So in this case that would be a 1. Now we take the 8 times the 1. 8 times 1 is 8. And now we combine like terms. Negative 13 plus 8 is negative 5. Now we do it again. 8 times negative 5 is negative 40. Combine like terms. Notice they cancel each other out. Nothing left to do in the problem, so that would be the remainder if there was anything. But 0 is the remainder. So there is no remainder. So what that means is, the answer to the question is yes. X minus 8 is a factor since there is no remainder. Now, moving on to example 4. Divide using synthetic division. So I know my outside number is going to be the 0 of x minus 2, which is positive 2. Now be careful when you set up your leading coefficients. We've got x to the 4th, and the leading coefficient of that is 1. But notice we're missing an x cubed term. There is no x cubed. Well, I have to put a 0 in as a placeholder as if there was 0x cubed. Now the leading coefficient of the squared term is negative 2 plus 5 and then minus 3. So I've got everything set up with my leading coefficients and my 0. So just start the process, bring the first one straight down. 2 times 1 is 2. Combine like terms, 0 plus 2 is 2. 2 times 2 is 4. Combine like terms, negative 2 plus 4 is positive 2. 2 times 2 is 4 again. Combine like terms, 5 plus 4 is 9. 2 times 9 is 18. Negative 3 plus 18, combine like terms again, is 15. Now there's nothing left to do, so that's the remainder. So my actual answer to this division problem is the leading coefficient is 1, but the degree of the polynomial went down by 1. When I divided x to the 4th by x, I got x cubed. So all you have to do is bring all of these degrees down by 1. So I would actually begin with 1x cubed plus 2x squared plus 2x plus 9. And now I have to make sure I get the remainder in the answer, plus 15 over x minus 2. So that's my answer. Now, if I were asked if x minus 2 was a factor of all this, the answer would be x minus 2 is not a factor, since there was a remainder. Example number 5 is related to problems 9 and 10 on worksheet number 6. You're given a polynomial equation, or function. You're given a polynomial function, and you're given one of the factors. So x plus 4 is definitely one of the factors of this 4-term polynomial right here. The question is, what are all of the factors? So what we're going to do is we're going to do some synthetic division to help us out. So if we know x plus 4 is one of the factors, then negative 4 is one of the zeros. And we're going to go in and put the leading coefficients. So 1x cubed, 2 for the x squared, minus 23 for the x, and minus 60. So what we're doing is we're basically dividing this by one of its known factors, which is x plus 4. We're just doing it synthetically. So the 1 comes down. Negative 4 times 1 is negative 4. Combine like terms. So that would be negative 2. Negative 4 times negative 2 is positive 8. So negative 23 plus 8 would be minus 15. And negative 4 times negative 15 is positive 60. And now combine like terms, and we get 0, which would be the remainder. And now, what is our function 1 degree lower? So this would be 1x squared minus 2x minus 15. And remember, there was no remainder. So now I'm left with this. And this is actually factorable, because what are the factors of negative 15 that give a sum of negative 2? And that would be x minus 5 and x plus 3. But don't forget about that one factor that we knew all along, and they told us from the very beginning that x plus 4 was one of the factors. So there's the final answer to this problem. If we knew for a fact that x plus 4 was one of the factors of this polynomial, we divided everything by the x plus 4 using synthetic division, and we got to this point right here, and then we factored this by our regular trinomial rules. And here's the final answer. Now we're on the last example for worksheet 6, example number 6. Now, the way I've worded this goes along with the wording of problems 11 and 12. If you were given 1, 0, and that's what this number is right here, that is one of the zeros, or the solution. Now, we already know one thing. If 3 is one of the solutions, then the factor that produced that 3 had to have been x minus 3. So, given one of the zeros, factor and sketch the polynomial function, label the x-intercepts and the y-intercept, and then graph. So, knowing that x minus 3 is one of the factors, which produces positive 3 as one of the zeros, I'm going to do synthetic division with the number 3. So I'm going to put 3 right there, and I'm going to use the leading coefficients of the polynomial, a 1, another 1, a minus 33, and a positive 63. And I'm just going to do my synthetic division. Bring the 1 straight down. Now 3 times 1 is 3. Combine like terms. 1 plus 3 is 4. 3 times 4 is 12. Negative 33, take away 12. Or add 12. Negative 33 plus 12 is negative 21. 3 times negative 21 is negative 63. Combine like terms and we get 0. And that's how you know we can go further, because there was no remainder. So let's take a look at what we've got right now. The polynomial drops by 1 degree. So this 1 means 1x squared plus 4x minus 21. So that's my new equation. Now, this is factorable. There are factors of negative 21 which add up to positive 4. And that would be x plus 7. And it would be x minus 3. But don't forget the one we knew in the first place. We knew all along that x minus 3 was one of the factors because they told us from the very beginning 3 was one of the zeros. So now we need to get that other one that we knew all along into the final form of the answer. So there is the problem in its fully factored form. Now I can clean this up a little bit and say y equals, notice two of the factors are x minus 3, so I can say x minus 3 squared, and then I can add the x plus 7 into the answer. So here's the problem fully factored. Now the next thing they want us to do is they want us to do some graphing. So let's take this, my x-intercept, are known to be positive 3 and negative 7. Now positive 3 is a multiplicity 2, which means when I do hit positive 3 on the graph, I'm going to bounce, not pass through. So I'm going to label my x-intercepts. One of them is positive 3, right here. The other one is negative 7. Now they also wanted to know the y-intercept. Now the easiest way to find the intercept is with the y-intercept is go back to the original function or the original equation in its unfactored form. Because you find the y-intercept by setting x equal to 0. Well, if that's 0, then that term is 0. That term is 0. That term is 0 because negative 33 times 0 is 0. The only thing that's left is 63. So you know that's your y-intercept at 63. So let's just put this up here somewhere where we think 63 might be, positive 63. Now the last thing we need for the end behavior for the graph is we need to know the end behavior. And that's based on the first term, the term with the highest power. 1x cubed equals positive, and the degree is odd. So the end behavior of positive odd is low to high. So put all that information in, and you should get a low to high graph. We're going to start low, because remember that was negative 7, and this was positive 3, and this is a bounce. That's a pass-through. So if I start low, and I come up, and I turn around and go back down, and then I come down, and I hit 3, and I turn around and go back up, there's the graph.